Now dear students, I am giving you a very easy method to solve the differential equation by using the Laplace transformation. The solution of initial value problems using Laplace transformation. I am starting the exercise. You will easily find a solution of the given differential equation by using the Laplace transformation. Question 1. Solve the differential equation by using Laplace transformation. This is a differential equation y dash plus 4y equal to 0 and y0 equal to 2.8 is the initial condition on the given solution. Now, what is the method? You understand very easily. First, we take the Laplace transformation on both sides of the equation. Laplace of y dash plus 4y equal to Laplace of 0. And by separate the Laplace of y dash plus 4 Laplace of y. Laplace of 0 equal to 0. So you know the formula. Laplace y dash equal to s ys minus y0 and Laplace of y equal to ys. These formulas we will use here. In this place we write ys0 minus y0. This is written over here. Laplace of y equal to capital Ys. We put here capital Y of s. Now by taking ys common we have s plus 4 and minus y0 taken right side. So this become Laplace of s plus 4 ys equal to y of 0. So put the value of y of 0 because y of 0 is equal to 2.8. So here we put y0 equal to 2.8. So s plus 4 ys equal to 2.8. Now the value of ys equal to 2.8 divided by s plus 4. Now taking inverse Laplace transformation both sides. We take the inverse Laplace transformation both sides of the equation. This becomes Laplace inverse ys and this is Laplace inverse 2.8 over s plus 4. Now you know Laplace inverse ys is equal to f of t. And this is constant term, we take outside the Laplace inverse function. So this becomes 2.8 Laplace inverse 1 over s plus 4. Now using this formula, this is the formula, Laplace of 1 over s minus a equal to e to the at. So here we use this formula. The value of a is minus 4. So in this place, we put the value of a is minus 4 since this become f of t equal to 2.8 e minus 4t. So y of t equal to 2.8 e minus 4t and this is the solution of the given equation. So where is the method to solve the differential equation having initial and boundary value problems by using Laplace and inverse Laplace transformation. First we take Laplace and then we take inverse Laplace. And ultimately we get the result y of t, that is the output of the given function. Now question 2, solve the equation using Laplace transformation. Y dash plus 1 by 2y equal to 17 sin 2t, y0 equal to minus 1. So again we repeat the step taking Laplace both sides. This become Laplace of y dash plus 1 by 2 Laplace of y equal to 17 Laplace of sin 2t. Now use the formula. We have s y of a equal to minus y0 plus 1 by 2 y of s equal to 17 into 2 over s square plus 4 square. Now Laplace of sin omega t equal to omega over s square plus omega square and y0 equal to minus 1. So we have this ys is common from this step. This become s plus 1 by 2 into y of s and this is equal to the value of y0, you know y0 equal to minus 1. So we put here y0 equal to minus 1 minus 1 minus, this become plus 1 and this is 17 to 34 over s square plus 4. Now plus 1 taken outside this right side to the right side, this become 34 over s square plus 4 minus 1. Now s square plus 4 is the LCM. So this becomes the equation 34 minus s square plus 4 over s square plus 4, and this is 30 minus s square over s square plus 4. Now we take s plus 1 by 2, dividing this s plus 1 by 2 both sides, we have ys equal to s square minus 30 minus s square over s plus 2 into s square plus 4. Now by using the inverse, now this become, by using the partial fraction method, we convert this fraction into the partial fraction as, by using method of partial fraction, this will become ys equal to 7 over s plus 1 by 2 minus 8s over s square plus 4 plus 4 over s square plus 4. Now taking the inverse Laplace transformation both sides, this become Laplace inverse ys equal to Laplace inverse 7 by s plus 1 by 2 minus 8s over s square plus 4 plus 4 over s square plus 4. Now Laplace inverse f of t become y of t, this is equal to 7 Laplace inverse 1 by s plus 1 by 2 minus 8 Laplace inverse s over s square plus 4 plus 2 Laplace inverse 2 over s square plus 4, by using the formula Laplace inverse 1 by s minus a equal to e to the at. So this become, by using the formula, this become 7 e to the minus 1 by 2t, and this is minus 8 cos 2t, and this is 2 sin 2t, and this is the required solution. Now question 3, solve the differential equation using Laplace transformation, y double dash minus y dash minus 6y equal to 0. These are the two boundary value problems. Boundary value conditions, you say y0 equal to 6, y dash 0 is equal to 13. Now again we repeat the step, taking Laplace transformation both sides. This become Laplace of y double dash minus y dash minus 6y equal to Laplace of 0. So this is the formula for Laplace of y double dash. This is Laplace of y double dash equal to s square ys minus s y0 minus y dash 0, and Laplace y dash equal to s ys minus y of 0, and Laplace of y equal to ys. So this can be written as Laplace y double dash minus Laplace y dash minus 6 Laplace y, this is equal to Laplace 0 equal to 0. So using these formulas to these steps, Laplace y double dash become s square ys minus s y0 minus y dash 0 minus Laplace y dash equal to s ys minus y0 and Laplace y equal to ys, this is equal to 0. Now taking ys as common, this becomes s square minus 6 minus s minus 6, this is equal to s y0 plus y dash 0 minus y0. Now put y0 equal to 6 and y dash 0 equal to 13. In this step, y0 equal to 6, in place of y0 we put 6, and in place y dash 0 we put 13, and in place of y0 we have 6. So this become 6s plus 7. So ys equal to 6s minus 7 over s square minus s minus 6, and the fraction of this is, we take the factor of this, s minus 3 into s plus 2. Now again by using the partial fraction method, this fraction become 5 over s minus 3 plus 1 over s plus 2. Now we take the inverse Laplace both sides. Laplace inverse ys, Laplace inverse 5 over s minus 3 plus 1 by 2. This is 5 into Laplace inverse 1 over s minus 3 and plus Laplace inverse 1 over s plus 2. Now using the formula, this term become e to the 3t, and this become e to the minus 2t. So Laplace inverse y is equal to y of t, 5 e 3t plus 2 e minus 2, the required solution of this differential equation. Now question 4, solve the differential equation by using Laplace transformation, y double dash minus 4y dash plus 4y equal to 0, by using the boundary conditions, y0 equal to 2.1 and y dash 0 equal to 3.9. Now again, taking Laplace both sides, this becomes Laplace of y double dash minus 4y dash plus 4y equal to Laplace of 0. By using these formulas, this can be written as Laplace y double dash minus 4 Laplace y dash plus 4 Laplace y is equal to 0. So we put these formulas in place of y double dash. This becomes s square ys minus sy0 minus y dash 0. In place of Laplace y dash, we put this formula sys minus y of 0 plus 4 Laplace of y is equal to capital Y of s. So in place of Laplace y, we put ys, this is equal to 0. Now this ys from this place, ys and ys, and from this place we take ys common. So this becomes s square minus 4s plus 4 into y of s, this is equal to sy0, this term taken right side, and this is minus 4 y of 0 plus y dash 0. In place of y0, we put the value of y0 equal to, this is 2.1, and in place of y dash 0, we put 2.9. So this becomes s into 2.1 minus 4, 2.1 in plus 3.9. So after simplification, we have s square minus 4s plus 4 ys equal to 2.1s minus 4.5. So ys is equal to 2.1s minus 4.5 divided by s square minus 4s plus 4. So we have ys is equal to 2.1s minus 4.5 divided by s minus 2 square. Now again by using the partial fraction method, so we have this third as ys equal to 2.1 divided by s minus 2 minus 0.3 over s minus 2 square. So taking Laplace transformation, inverse Laplace transformation both sides, this becomes Laplace inverse y of s, Laplace inverse 2.1 divided by s minus 2 minus 0.03 divided by s minus 2 square. So this is equal to Laplace y is equal to y of t, 2.1 Laplace inverse 1 by s minus 2 minus 0.03 Laplace inverse 1 over s minus 2 square. So again using this formula, this can be written as 2.1 e 2t, and this is minus 0.03. This is the formula t e 2t. From this formula, this become t e 2t, the required solution. Now question 5, solve the differential equation using the Laplace transformation y double dash plus 2y dash plus 2y equal to 0, y0 equal to 1, and y dash 0 equal to minus 3. Again we repeat the step, taking Laplace both sides, this becomes Laplace y double dash plus 2y dash plus 2y equal to Laplace of 0. Now Laplace y double dash plus 2 Laplace y dash plus 2 Laplace y equal to 0 by putting the formula of Laplace y double dash, and this is the formula of Laplace y dash and Laplace y equal to y of s. Now you see, after simplification, this will become s square plus 2s plus 2 into y of s is equal to s y0 plus 2y0 plus y dash equal to 0. So value of y0 is 1, so we put here 1, and y0 equal to 1, and y dash 0 equal to minus 3. So this become s minus 1. Now ys is equal to s minus 1 divided by this term divided both sides, s square plus 3s plus 2, this is equal to s minus 1 divided by s plus 1 square plus 1, this is equal to s plus 1 minus 2 divided by s square plus 1 plus 1. So by using the partial fraction, this becomes y of s is equal to s plus 1 divided by s plus 1 square plus 1 minus 2 over s plus 1 square plus 1, taking inverse Laplace both sides, Laplace inverse y of s, Laplace inverse s plus 1 over s plus 1 square plus 1 minus 2 over s plus 1 square plus 1. So Laplace inverse y is equal to Laplace inverse s plus 1 over s plus 1 square plus 1 minus 2 Laplace of 1 over s plus 1 square plus 1 square. By using the formula, Laplace e at sin omega t is equal to omega over s minus a square plus omega square. Laplace e at equal to cos omega t equal to s minus a over s minus a square plus omega square. So this step become e minus t cos of t, and this is minus 2e minus t into sin t by using this formula and this formula, taking e minus t common. So we have, this is f of t equal to e minus t cos t minus 2 sin t, the required solution of this question. Now question number 6. Solve the differential equation using the Laplace transformation y double dash plus k y dash minus 2 k square y equal to 0 under the boundary conditions y0 equal to 2 and y dash 0 equal to 2k. Taking Laplace both sides, this become Laplace y double dash plus k y dash minus 2k square y is equal to Laplace of 0, Laplace 0 equal to 0, and this can be written as Laplace y double dash plus k Laplace y dash minus 2k square Laplace y equal to 0. We have s square ys minus sy0 minus y dash 0 plus k sys minus y0 minus 2k square yfs equal to 0. Now taking ys common, we have s square plus ks minus 2k square, and this become s y0 minus plus k y0 plus y dash 0. Putting the value in place of y0 equal to 2 and in place of y dash 0 we put 2k. So here y dash 0 2 and y dash 0 equal to and y dash 0 equal to 2k. So now after simplification, this become 2s plus 4k. So ys is equal to 2s plus 4k divided by s square plus ks minus 2k square. So this factor of this term is s minus k s plus 2k, and this is 2 into s plus 2k over s plus k into s plus 2k. So this term will cancel. This is equal to y of s equal to 2 over s minus k. Taking inverse Laplace both sides, this become Laplace inverse 2 over s minus k. This is 2 into Laplace 1 by s minus k. 2 in this become, by using the formula, this is 2 into 2e kt. So Laplace inverse ys equal to yt, and this is equal to 2e kt, the required solution of the equation.